Hello, here's an example on how to find out the determinant of a 4 by 4 matrix. We have this 1 2 3 4 by 1 2 3 4 matrix. As you know, 4 by 4 matrix is a matrix containing 4 rows and 4 columns. We have this 4 by 4 matrix and we aim to find the determinant of this 4 by 4 matrix. Before I get on to the working, essentially what we have down here, I would like to make you aware, or actually bring to your notice, this formula up here. This formula is the formula for cofactor. So the cofactor for this position is -1 to I plus j times the determinant of this submatrix M. That was a review of the cofactor. So keeping this theory in mind, let's begin and let's see how we can compute the determinant of this 4 by 4 matrix. What we do is we pick any of the 4 rows. Let's pick the first row. In the first row we have 2, -1, 0 and 0. So I think you remember from the theory of determinant that we pick any row. For instance, here I have picked the first row. We visit each entry in that row and then multiply by the cofactor and then just sum up. For the first row we have 2, -1, 0 and 0. Now these two zeros would not play any significant role, so let's just focus on these two non-zero entries, 2 and -1. So we have 2 and -1. But that's not just it. We take 2, multiply by the cofactor. So the position of this entry is 1 1. So we multiply 2 by cofactor for the position 1 1. Plus we go to the second entry, which is -1, and then multiply -1 by the cofactor for position 1 2. So -1, the position of -1 is row 1 and column 2. So row 1 and column 2. Next we have 2 times this cofactor. As you know that in order to find C11, we do C11 is equal to -1 to the 1 plus 1. So -1 to the 2 is essentially 1. So here we have 1, but I'm not showing that 1 right here. And then we have a determinant of a submatrix M11. So if we try to find C11, we should again have M11. M11 is the submatrix that would show up if we just hide what we have in the 1-1 position. So this is the 1-1 position. Let's hide this. And what exactly do you see then? What you see is this matrix, right? We have 2, -1, 0, and then -1, 2, -1, 0, -1, 2. That is exactly what I have right here. So M11 is 2, -1, 0, -1, 2, -1, 0, -1, 2. Okay. Then plus -1 times C12. Let's try to find C12. Let's get to this formula. C12 is equal to -1 to the 1 plus 2, which is 3. -1 to the 3 is -1. So that -1 is actually shown right here. So plus times -1 generates this negative sign, and then from C12 this -1 shows up. I repeat this. So this negative sign is due to -1 up here, and this -1 shows up due to C12. So C12, let me just show it right here. C12 is equal to, so C12 is equal to -1 to the 1 plus 2, and then the determinant of the submatrix 1, 2. And then we have, so -1 to the 3 equals -1 times the determinant of the submatrix 1, 2. This -1 is exactly what I have right here. So C12 is equal to -1 times the determinant of the submatrix. So the -1 is right here, and determinant of the submatrix is right here. So M sub 1, 2 means what we see after we hide out the column and row from 1 to position. So we go to the 1 to position, so 1, and then 2 position is this. So we try to hide what we have in the 1 to position, and what we see is a -1, -1, 0, 0, 2, -1, 0, -1, 2. We put that right here. So determinant of the submatrix is determinant of what shows up right here, determinant of this. Okay. Now that we got to this point, note that we're still not done. We still need to find the determinant of these 3 by 3 matrices. Let's do that. So 2 is right here, and then we need to find the determinant of this 3 by 3 matrix. We start with any row. I'm starting with the first row. I have 2. And then I will have to work with -1, which shows up right here. Now we take 2, multiply by the cofactor for this position. So the cofactor for this position would be C11 is equal to, so I go to this position, I hide that column and row, and I see 2, -1, -1, and 2. So as per this formula, I apply this formula to find out the cofactor for this position. So C11 is equal to -1 to the I plus j, 1 plus 1, and then the determinant of submatrix capital M 1 1. So -1 to the 2 times the determinant of the submatrix for the position 1 1. So -1 to the 2 is just 1, hence I just don't do anything right here, but we have this determinant of M11. Determinant M, the submatrix for position 1 1, is what we actually noticed as we hid the column and row for that position. So 2, -1, -1, 2. Two, -1, -1, 2. Okay. So C11 is just the determinant of 2, -1, -1, 2, as you can see. And then, so we're done with the cofactor of 2. So we had 2, and then we multiplied 2 by its cofactor. And the way we find cofactor is by using this formula. Next we move on to -1. So plus -1, and then we need to multiply -1 with the cofactor for this -1. So the position of -1 is 1 2, and to find out the cofactor for 1 2, we use this formula. So -1 to the 1 plus 2 times the determinant of submatrix 1 2. -1 to the 3 is -1, so that -1 shows up right here, and then the determinant of this submatrix. So we have negative 1, negative 1, negative 1, negative 1, 0 and 2. Negative 1, negative 1, 0 and 2. So C cofactor for the position 1, 2 is just negative 1 times the determinant of negative 1, negative 1, 0 and 2. This is exactly what we have right here. So here this whole thing is the determinant of this 3 by 3 matrix. Next we need to work on the determinant of this 3 by 3 matrix, just like what I've done for this 3 by 3 matrix, just like what I've done to compute the determinant of this 3 by 3 matrix. You can follow the same procedure and find the determinant of this 3 by 3 matrix. Once you do that, you will get something of this form. Next, it's just all very easy. So we have 2 and then 2 times the determinant of this 2 by 2 matrix. So 2 times 2, 4, minus negative 1 times negative 1, which is 1, plus minus 1 times minus 1 is 1. Negative determinant of negative 2, determinant of this 2 by 2 matrix is negative 2, plus 1, we have this one is this 1 right here, and then inside negative 1 multiplied by the determinant of this 2 by 2 matrix, plus this will turn out to be 0 anyway, because when you try to find the determinant of this 2 by 2 matrix, it's just 0. So this whole thing becomes 0. Okay, so once you find this, it's just all algebra. 2, and inside I have 2 times 3, which is 6, plus negative 2. So here I've written 6 minus 2. I repeat, 6 minus 2. This is not plus, this is a minus sign. Then plus 1. Here we have minus 1 times 3, which is minus 3. So 2 times 4 is 8, and from this we get negative 3. So 8 minus 3 gives us 5, and 5 is this. 5 is the determinant of this 4 by 4 matrix. As a summary, I would like to mention that in this example, I was trying to find the determinant of this 4 by 4 matrix. In order to do so, I had to at first go through the formulas, and as I tried to continue with these formulas, I actually had to find the determinant of these 3 by 3 matrices, and then I had to find the determinant of these 2 by 2 matrices. So you see where what my point is. To find the determinant of a 4 by 4 matrix, we actually had to use the determinant of 3 by 3 matrices, the determinant of 2 by 2 matrices. This is how we find the determinant of a 4 by 4 matrix. Hope this helps. Thank you.